Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're a Meetup group. We do in-person and online sessions, especially for people starting off in Python and for those who are interested in machine learning. So tonight we're going to be looking at how to use Python with Podman. And Podman is a container environment like Docker, and we've done a session on Docker before, so I thought we'd try Podman this time and just see what the differences are and the similarities between them, and how you can use it to isolate your environment from other components of your operating system and other applications that are installed. So I'm a big fan of virtual environments and isolated environments to make sure that you've got a very good control over exactly what's installed in the environment that your application is running in. Now we can, this is a live stream, so you can send comments. We've got the chat channel, Learning to Code, which is part of Beginners Python and our Slack group that we're in, and there's instructions below in the video that tells you how to join that. If you haven't joined yet, then you'll be able to send just messages in the YouTube chat, and I'll keep an eye on those as we're going along. Okay, so the hardest thing with Podman and Docker as well is just installation. Anyway, let's get into the script. So if you look in the Meetup event, or if you look down below the video you're currently watching, the first thing I've got is a hyperlink to our GitHub, which will give us the script. So if you click on that link, it'll bring up the script. I've got the wrong date in there, but this is a script that we'll be following tonight. And let's see, so it should work. Most of it will work on Windows, Mac, and Linux. I'll be doing it on Windows 10, and so there's just a couple of slight differences. So I'll just read through this. Podman's an alternative to Docker. Oh yeah, so Docker Engine is free. Docker Desktop, which a lot of people use to give you a graphical user interface rather than the command line. It's free except for commercial use in a company with 250 employees or more. And Docker has been trying to raise revenue streams as well, so the Podman came around. I think it's strongly supported by Red Hat to give a totally free solution. So there is a Podman Engine and Podman Desktop, and they're both free and highly compatible with Docker. You can manage Docker containers with Podman, and vice versa. Podman's got a couple of differences. It's daemonless, which solves a problem I was having when I was running Docker. It was getting controlled between when I was running Docker Engine or just Docker Desktop. And Podman has rootless containers, which is a really good thing. If you can run everything without having to be root, then you can really improves the security of your installation. Not that there's many problems really with Docker, but you just have to be a lot more careful when you're with Docker. So I've got instructions here on installing. So I'm doing the Windows one, so I've gone to this link here. And in this link, it describes how to install Podman for Windows, and it really needs Windows subsystem for Linux installed. So it says WSL v2, which I think is now just called WSL, but it will install that for you automatically. They also recommend installing Windows Terminal, so I've done that. I've done winget install Microsoft.Windows Terminal. So you might want to do that first, and then we'll be using Windows Terminal tonight. Then to install Podman, you have to go to the GitHub release page. So there's a link here. So let's go have a look at that. And the latest one, which I've just installed, version 5.4.0, just came out in the last week. And it talks about all the things it can do. And there's a bunch of installers. So we'll go for this first one, Podman 5.4.0-setup.exe. Now when you install that, you do have to, it appears you do have to authenticate up to administrator level, so it can be installed. But that's just, I think, for the WSL part of it all. Once that's installed, then you can run it without requiring administrator access. So if you haven't done that yet, try installing Podman 5.4.0. Okay, and then once it's installed on Windows, you have to run this command, podman machine init, and that'll do an automatic WSL installation if you need, and set everything up. And so this is what it will look like when you do podman machine init, and then it'll get down here and say, now to start everything, you type podman machine start. So that's where I'm up to on my installation. So I'm going to open Windows Terminal, and I'm going to type podman machine start, and it says it's already running, and that's true. I just started it before. So let's try stopping it and starting it. Just make sure, see if we get the right messages. Okay, so it says we're currently configured in rootless mode, which means you can run them just as a normal user. If you really do need to use network ports that are less than port number 1024, then you will have to set root full. Otherwise you're going to run into issues, and that's just a way operating systems are designed, that you need to be root to work on ports less than 1024. I'm not going to be doing anything less than 1024 tonight, so we can ignore that for now. Okay, our Podman machine default has started successfully, and so let's go on to the next step. So started the machine. Oh, and it tells you how to run stuff. So let's go back to my script, and we'll get started. Now, we're giving you a few references here to Podman, a couple of cheat sheets. So Red Hat give you some Podman stuff, and also some information about the Python Docker images that we're going to be using with Podman tonight. Okay. All right, so if you may remember, Docker had a Hello World app, so let's try the Podman Hello World. So in Docker it was just Docker run Hello World. In Podman it's going to be Podman run. It's going to be hello, but it's we're going to specify explicitly where it gets it from, rather than rely on it just searching through a registry of places where it can find images from. And I always like to be explicit. So if you type this into your Windows terminal after you've started your machine, and then run it. Now I've run it before, so it's actually downloaded the image and created the container, and then run the container. When it's finished running the container, when it just quits, because there's nothing more to run in this one. All it does is just do a little bit of ASCII art and give you a few links. But we know that Podman's installed successfully if we can get that far. Okay, now we'll try doing it on the Docker one. So we can try Podman run Hello World, and that used to give us the Docker Hello World. Although now I notice that they've Podman have put their hello image into the registry under the name Hello World, so you'll also get the Podman Hello World. But we could specify explicitly to get the Docker one by saying we want to get the one from docker.io/library/hello world. So let's try running that. Okay, so it's got to pull the image this time because there's no cached copy on the local computer. So it does a bit of verification on the image that it's going to get. It copies it down, so it's gone and copied down a container containing an entire operating system onto our local computer, and then run it. And it gives us this message, hello from Docker, because it thinks we're running Docker, but it's just a Docker image we're running in Podman. And prints this all out and stops. Okay, so that's showing an example. Now we'll go into a bit more detail, and so you'll actually understand what's actually happening in this process. So I suggest let's create a directory called Beginners Python and Machine Learning, session 212, Podman. Okay, and we'll change directory into that. Got some old ones there. And we'll make a directory. Now we could call it anything we like. This is a task for you to do, so I've called it task hi from pi. So we're going to write a little Python program that's going to say hi, and we're going to run it. We're not going to run it on our computer with our local installed Python. We're going to run it in a Podman container. Okay, so we've created that directory. I might do this in Notepad++. Okay. So we're going to create a little Python program, and all this program does is import the sys library and then says hi from Python and tells us what version of Python we're running. And we're going to save that into the folder we just created, and we're going to call it hi from .py. And now, because it ends in .py, Notepad knows it's a Python program, and it's done a bit of syntax coloring for us very nicely. Okay. Now we're going to create a file in the same directory that's going to define an image that we want to create. So this is going to be called a container file, or if you want to stay compatible with Docker, you can actually call it the Docker file, and that will work also. In Docker, remember, we call them Docker files. Here we'll just call them container files. And it's lowercase f for some reason, and it's got no file extension, so I don't want an extension. Okay, so let's run through the steps that we've got in this container file. So the from command is, you always need to start in a container file to say what you're starting from. So we're going to find an existing image that we want, and we want Python 3.11. So let's just before we do this, I'll just check what version of Python we're running. So we've got 3.12.2 installed on our computer, but we want to run this in Python 3.11. Okay, we'll pull back up that. Now we're going to create a working directory in the container, and that's the run command entry point and copy. So run command entry point copy and add instructions all use this working directory, and if it doesn't exist, it will be created when the image starts running in a container as a container. We're going to copy some files into the container, and we're going to say copy dot, meaning the current directory, and store them in the working directory. So really the file that we're going to copy in is going to be called hi-from.py, which you can see there. That's the name of it, and the entry points is what we're going to do with it once we've copied it in, and we're going to run it as an executable. So it'll run Python space hi-from.py as though it'd run it from the command line, and it'll do that when the container is run, and then the container will quit when it's finished. So we're creating like a whole operating system that's got Python 3.11 installed on it. We're copying in our Python file script that we want to run. We run it when when the container starts running, and then when the script finishes, the container will stop running. So that's what's going to happen. Now we could also do things when we're building. We could have say run commands, for example, run pip install -r requirements.txt. So that'll install all your third-party libraries that you need, and it'll do it when the container the image is being created, not when the container is being run. Command is something you can run when the container is being run, similar to entry point. And I've just got some things there. You can set environment variables with env commands. Okay, so let's try building and running this container. We're going to do it in the current directory, so let's jump down to our terminal. We'll change directory into the task hi-from.py directory, and now we're going to build. So we use the Podman command, and it's going to be build. Now we're going to tag it. So this is the from Py image, and what it's going to get its details from is any container file or Docker file that's in the current directory. I could specify it explicitly, or I just say dot for current directory. So remember to put the dot at the end if you didn't see it there. And now it's creating the image. So the first thing it has to do, it has to pull an image for Python 3.11 from the main repository of original images. Then it's and that might take a little bit of time, as it is in this case, to download. Then it's going to create a new image which will be based on that image, but have those slight changes that we've just made, which is we want it to have, we said what the working directory is going to be. We're going to copy in that hi-from.py text file into there, and then we're going to run it with the Python command. Okay, so that's done that. It's created the working directory, it's copied in the files, and it's said what the entry point is going to be when we run the container. And it's been tagged, so it's going to be tagged as this name, which was what the -t did. ppaml 212 hi-from.py image : latest, because we didn't specify a version number. And so now it's ready to be run. So the next command to run it is this one here. So we built it, now we can run it. Podman run and we just need the tag name of the image, and it'll default to :latest. So if we press enter on that, it'll run it, and there we go. It says hi from Pi 3.11.11. That was compiled on February the 4th, 2025, using the GCC compiler 12.2.2. So that seems like a lot of work to run a very short Python program, but we'll start to do some more complicated things, and you'll start to see how this can really benefit. Like, we're going to run a web application that's going to be linked to a web server, and we're going to have a database, and we'll run it all in containers. Now remember, imagine setting all that up in your normal operating system. You wouldn't know how, but with just a few Podman commands or Docker commands, we can show you how to do it. Now I've given you just a few other Podman commands here. Let's try a couple of them. Podman PS, view any running containers. So you just type Podman PS, and it gives the headings, but there's no containers currently running because it quit. But we can do Podman PS-A, and that'll include any containers that currently exist that that have stopped, and so they're just sitting there not running. Now we can remove any of those that we want. You don't normally run an existing container. You should assume that everything in your container is going to be lost. So if you want some persistent data, later on I'll show you how to link to I think I'm going to show you how to link to an area where you can store persistent data, so that the container can be lost, but the data is still there that you can use in another container. We can remove any container using the container ID, and we can just use a partial ID. So if we make these a bit wider, you can see the IDs a bit more easily, and we just have to type in a little bit of that. So if we say Podman RM 3F43, it removes that that image and that container which has had an image, because we don't need it anymore. And we could go through and do that for all of those. Maybe let's do a few more, because we don't need any of these anymore. So you can see a fresh slate. We've got no containers currently in our area. And there's some more things which we don't need to really worry about for now. Okay, so we want to run a Flask application. So Flask is a way of writing web applications in Python, and our group has actually written one before, which is showing relationships between prime ministers and deputy prime ministers of Australia, and just giving a bit of a history of when they were born and etc. So let's create a directory for this one. I'll call it task flask. Could be called anything. I'm just putting the word task in the front because it's a task for you to do. In there we're going to create a container file. So I'll copy that, and we'll create a container file in Notepad. It's a bit easier. And so if I save that, I don't want it in task-pi. I'll put it in task flask and call it container file. And there it is. So what it's doing, it's using Python 3.11. It's got a working directory. I've called it the same this time. It's going to go to GitHub and clone this repository, BPAML Prime Minister, and that's going to be stored in the directory BPAML212. Once we've done that, then we can create another working directory called BPML Prime Minister, which is the one that now exists because we've now cloned this repository here. And notice I didn't put a slash at the front so that it's relative to the last one. I'm going to set an environment variable called pip root user action equals ignore, because I want to run these pip commands, and I'm going to be root, not in the host operating system, the Windows that I'm running. I'm going to be root in the container. And some people go to the extra length of actually making sure they don't run as root in the container. But for now, let's just not try too many difficult things at once. And we're going to run as root in the container our pip command, which is highly discouraged by the Python people, even though it's reasonably okay in a container to do it. So I've just set that environment flag to say ignore any warning, ignore that we're doing this, and stop, and don't give us any warnings. And that's just to get rid of some warnings. Then I'm going to run flask initdb, which is going to create a SQL-like database for us with the Prime Minister data in it. And then it's going to run it, and it's going to allow hosts from anywhere on the local network. All right, so let's give that a go. So here's the command. So I'm going to change directory into task flask. I'll just highlight what I'm doing. Then I'm going to build my image. That's going to be based once again on Python 3.11. And we'll call this one BPML 212-flask. And it's going to use the container file that's in the current directory, so I'll put a dot there. And now it was much quicker getting Python 3.11 this time because it's been cached locally. And so it's managed to do it all. And now you can see it running the pip command, so it's installing all the third-party libraries that we need for this to run. And that's all installed on the image. And so now we can create a container on that image and run the container. So the command I'm going to do for that, Podman, I'm going to run a container. And after it's finished running, I'm going to automatically get it to delete. So I just do --rm. Rather than me having to go through and find the old containers and delete them. So I'll just do --rm and it'll remove it automatically when it's finished running. And that's what most people will do. Now I want to publish a port. So inside the container, Flask is just running in development mode, and it will be publishing on port 5000. But to show that we're actually not looking at it in the container, and that we're actually looking at it, that it's not running on the host, it's actually running in the container, we're going to say translate any port 5000 network traffic into port 4000 on our host. So let's choose 4000, and the 4000 you can make up any number you like. The 5000 at the moment, it has to be 5000 because that's what Flask will be using. You'd have to change your container file to tell Flask to use a different port number if you wanted to have a different port inside the container. Okay, so we're going to run that image, and we do that. Alright, so it's telling us this is a development server, do not use it in production deployment, and we can look at it on port 5000, but this is the messages from inside the container. We're going to look at it on port 4000. So if I just go up to here, in fact I put a link, there we go, there's a link here. I can just click on this, open a new tab, and there's our application running. Now if you can remember, or can you imagine what instructions I'd have to give you to install this web application so it was running, and you could look up all the Prime Ministers of Australia or the Deputy Prime Ministers, have it running and coming out on a web browser. I mean, it's fairly involved. Over here on the right we can see the log messages every time I click a link. It just tells me what URLs I've been using for it to return data. So using these containers made it a lot easier. I could have just even given you the container file and you could have just run it in Podman, or even I could put the image that I've now created up on a repository somewhere, and you could have just said Podman run a container based on that image that it would download and automatically run it, and it would have part of the network stuff all set up for you. But it is running through the development server stuff, which is not ideal. But anyway, let's move on. So we're going to quit this. So it says press Control-C to quit. So I'm in the terminal. I'm going to press Control-C. That worked. It quit my it quit the app, and once the app was finished, then the container can just shut down, and once it shuts down, it automatically removed itself. So if I type podman ps-a, I now don't see any containers running or otherwise. So we're going to use a proper WSGI server called gunicorn, and so we're going to install it on the same in the same container as Flask is running. So to do that, let's create another folder. And in there we're going to create a container file. Now this one is not going to be based on Python 3.11. This one's going to be based on our Flask data file. So it'll take everything that was used to create our BPM AML 212-Flask image that's stored and cached locally, and then it's going to set the working directory, which is going to be the same as before, and then it's just going to install one more thing, which is gunicorn, and then when it's going to run, it's going to run this command. So if you look at the previous one, we've got a command running Flask, and then we've got another command here running gunicorn, and it's also then going to run the Prime Minister create app method. So the Flask run command is not going to be run, it's just going to be this one here. So let's save that as container file in task gunicorn, and let's try to run it. So I need to change directory into that directory. I need to build the image. And it's going to be based on the container file in the current directory, so remember to put the dot in. And there we go. Now the image that it's basing it on is locally cached, so in fact that's the only place it's stored, so it doesn't take very long at all to use it. And then it's just got to install gunicorn, which doesn't take long as well, and it's all ready. So let's try running this, and this time now gunicorn will run on port 8000, so we're going to map that to port 7000 on our local host. We could do 8000, but we might have gunicorn already running somewhere else locally, so we can get this one to run on port 7000 if port 8000 is already used. --rm, so it automatically removes itself. Sorry. Okay, so starting gunicorn, listening on any address on the local network on port 8000. So that's what will be running on the container. So let's have a look on port 7000 on our host operating system. And once again, it's working. So we can see people, prime ministers, deputy prime ministers. We can go in and have a look at anyone, find out when they're born or died, and who was the concurrent minister. So he was deputy prime minister when Bob Hawke was prime minister. Very good. Alright, so gunicorn is what they call a WSGI server, and that's really to get the automatically generated HTML, server-side HTML from the Python application to somewhere else. And normally you'd send it to a proper web server like nginx or Apache 2. So we're going to use nginx here, and we can run nginx in a different container. So we can have two containers running and they talk to each other. And gunicorn will be running on one, and the requests from nginx will go back to the gunicorn one, and which will take it through to the Python app, and then the response will come back from the Python app, go back to nginx, and then eventually get to the end user. So we need to we're going to use nginx in a container file from nginx. They've set one up for us that we can use, and we need to create a configuration file for it. So the configuration file is going to look like this. This is just a way you configure nginx to work with gunicorn. We're going to be listening on port 80 and just really pass everything through to port 8000 on the gunicorn one and set some headers. Alright, let's copy that. And see we've got here the name con gunicorn. That's the name of the container that we'll be running, and we can use that in the network address there for telling nginx how to connect to it. Alright, now I'm going to do Control-C to stop that other container from running. And we'll create a directory. I'll call it task again, nginx. Let's go into Notepad++, and we'll create our configuration file, and we'll call it nginx.conf. Okay, then we'll create a container file. So we're going to say we want to use nginx version 1.23. We're going to remove the existing configuration for nginx, and we're going to copy our new configuration from the host system into it to build our new image. So let's save that as a container file. I can type it in, can't I? Okay. Now, because we're going to run two containers and they need to talk to each other, there's a couple of ways we could do this. If we were doing it on Docker, we would create a network. So let's do the same thing in Podman. I'll change into the nginx directory. Didn't need to yet, but I'll create this network. Podman network create, and we'll call it NW for network, bpaml212. And so any container that we start, that we can tell that we want it to use that network, and then it'll be able to communicate with other containers on that same network. Okay, let's build our image. And it's going to use a container file in the current directory, which is task nginx. So it's got to pull the nginx image version 1.23 from the main repository on the internet. Then it's going to delete the configuration file and put in our configuration file. So that's all set up. Now we're going to run them. So let's start them. I'm going to start our gunicorn one first. So let's have a look at the command here. We're going to do run it. After it's finished running, we're going to just remove it automatically. The -d, that means we're going to run it detached, which means that before, you saw when we ran them, they took up my command line. Like I had to press Control-C to get back to the command line, and that also quit the container. So by doing it detached, it'll just keep running, and I can close my terminal and not have any problems, and it'll be just running away in the background. I'm going to give it a name, gunicorn. I'm going to tell it to use the network that we've just created, and I'm going to use the image that we created before when we're doing the gunicorn one. So let's paste that into Windows Terminal, and it's now running, and it's detached, so I can start running more Podman commands, and I can see that I've got my image called gunicorn, or the container called gunicorn, that is running based on this image bpaml212-gunicorn. And that means I can actually run the second command here from the same terminal. And so it's running as well. If I do podman ps, I can see I've now got two containers running, and they should be talking to each other. So let's test. Now, what have I done here? Oh yeah, so when I ran the nginx one, I said anything on port 80, I want to expose on port 8888. I couldn't choose 80 because I'm not running it as an administrator user. And so if you're doing this on a server, you would want to be running any web traffic out through port 80 or port 443 for secure stuff. That's 4,000 from before, 7,000, they're not really running anymore. And there's 888, let's check it's running. Yep, that's all running fine. So let me know if you manage to get the Prime Minister web application running, because yeah, it's always interesting. Or ask any questions if you had any problems at any part of it. Okay, now I'm going to cd back to the parent directory. Alright, we've had a look at what containers are running. Let's now stop them. So I can just, and I can use names this time because I gave them names when I started them, so now I can stop them using names rather than, otherwise I could use container IDs. But with the names, we'll stop them, and that's instead of typing Control-C like I did before. So podman stop nginx gunicorn, and it stops them both. So now if I do a podman ps, there are no containers running. And if I go to my app here and I try clicking on something, it'll just time out, can't be reached. Okay, now I did this on Ubuntu, and I was getting network errors. I don't know why. I tried everything to try to stop them. or work out what. If I ran as root, it would fine. I didn't get the network. It just said I didn't have permissions to shut down the network, which seemed very weird to me. I wasn't using any ports lower than 1024. So I then tried another way of doing a similar thing. This time, rather than using the network, which is the Docker way of doing it, I use a Podman pod, and this one worked. So let's try that. So it's a bit similar to a network. We're going to create a pod, and we're going to say that anything inside the pod on port 80 is going to be exposed on port 888. And now any container that we put inside this pod, it can then talk to each other over the network, but it can't talk remotely. The only thing that's going to get out remotely out of the pod is this port that we've exposed by using setting port 80 from the pod out to port 8888. So we're then going to start the containers. It's pretty much the same way as before, except this time rather than -- network and the network name, we're going to do -- pod and the pod name. Everything else is the same. For the nginx container, we don't have to do the port exposure when we run the container. We actually do it when we create the pod. So let's run these 3 commands. Paste anyway, 3 commands. There we go, that's running. We'll go have a look at our port 888. Yeah, we can run it. So that's now working through the pod rather than through the network. So it's just a different way of doing it. I suspect it gets a little more care and love than the network command. The network command is just there so they can be compatible with Docker, but the pod command is where the Podman people really see everything going. So I'd probably use it in preference. It gives you a couple of things. You can also do, like you can Podman PS will once again give you all the containers that are running, and it includes this first one, which is actually a pod. So it runs a container for a pod and then a container for each container that we've got running. We can also do Podman pod PS, and it'll just tell us which pods are running, and there's just the one of them. In fact, we can just stop that one pod. Stop pod bpaml 212. And now if I go and look at which pods are running, and it says it's exited. If I want to see which containers are running, no containers are running at all. So that one command stopped all the containers that were in that pod, so that's useful as well. And now I can remove that pod rm bpaml 212 with the word pod in the front. It doesn't have to have the word pod. I just call my pod with a pod. So with all these names floating around, I don't get mixed up as to what it's actually naming. That's been removed, and so if we now look pod PS, it's not in the list. Okay, and the beauty of that was I got no warning messages when shutting down, even when rootless on Ubuntu. So are there any questions after all that? I find it useful. So the question is, should you use Docker or should you use Podman? I think give Podman a go, but if you're following instructions from somewhere else and they're using Docker Compose, I'd probably prefer to use Docker on that. There's a Podman Compose as well, but it's a little not quite as well written, I don't think. If you're doing stuff that you're not really sure about, and you're trying to follow documentation on the web, most documentation is going to be for Docker, the Docker way of doing it rather than the Podman way of doing it. Docker is probably the easiest in those cases. Just go straight with Docker rather than try to use Podman even in compatibility mode. But if you're getting pretty experienced with Docker, then yeah, give Podman a go and then you can start working on things like running it rootless, which is more secure, but security is all about just stopping things working, so it's harder to get things working when you're running rootless. And it runs without a daemon, so that's really nice. It's got some Podman's got some really nice features. I've been playing around with a thing called Podman Quadlets, which on a Linux computer helps you link in with systemd, and it's a really good way of getting your containers or pods to run as services in the background, like running as daemons. So even though it runs daemonless, sometimes you want to run it as a daemon, and so it gives you a way of doing that, and you use Quadlets to set that up. Okay, I'm going to assume there's no questions. I hope you enjoyed it. We're looking for presenters who want to present machine learning topics. If you want to do that in person, then just contact us in Slack. Send us a direct message or even on one of the channels. And once we've got that, then we can book a session at Amazon Web Services or Amazon offices in the Brisbane city, and they've got a lovely venue there for us to present. If you've got any requests for topics, you could send them as well, and we'll see what we can do. Thanks to Shivnit. I'm glad you enjoyed it. I get a bit worried when I get no questions. I wonder if anyone's watching. But yeah, I think this is a very powerful tool, and I hope I showed you how to use it with Python. And one bit of documentation I think I should point out is this one here, hub.docker.com _Python. That's the documentation on how to use the Python image, and the other images will also have a similar documentation. So like if you wanted to know how to use the nginx one more than what I've explained, or the Python one, then go to those documentation, and it explains how you can use it and how you can expand on it, build from their image to another one. Okay, good, you went through the module before on GitHub, so I'm glad that worked for you. Sometimes I find mistakes at the last minute, but yeah, this one went through very smoothly. Yeah, thanks for that. And you can even the other sessions on the repo have actually got links to YouTube videos. You won't be able to watch them live, but they're still there, so you can watch them as well. And if you need any more explanation, they might be in the videos. Okay, that's all from me. Until next time, I think Arun will be presenting next week a machine learning topic, so that could be fun. Bye.